Right, so here we have ethene reacting via reaction A with hydrogen bromide to give us compound A. Compound B is an alcohol by reaction B. And then we have hydrogenation addition there of hydrogen gas to give us ethane then. And ethane reacts by combustion to give us compound C. Now, the thing here is that we must try to identify as many things as possible here. So now the first thing that we're going to say is that we're going to say that these reactions, A, B, and hydrogenation are addition reactions because they come from an alkene. So they are reactions where a double bond is going to be broken and then we are going to add something then. So the question then is that we add what? For both of them is clear. For reaction A is clear, we add hydrogen bromide then. So it means that for reaction A, what's going to happen is that we have two carbons. This is ethene. Ethene here, we have two carbons over there. And then what happens is that now, when you break the double bond there, for that one, for reaction A, on one side, you are going to add a hydrogen, and for the other side, you are going to add the bromine there. And your product is simply 1,2,1-bromoethane there. And then now we can go to reaction B. Look at reaction B again. Let's see what we have there. What we have there is we have that ethene of ours. And then when you break the double bond there, in order to have an alcohol, it must be hydration. And hydration is the addition of water. Now you look at water H2O. We must see it as HOH. H2HOH, meaning a hydrogen and a hydroxyl. It means that we are going to add a hydrogen and a hydroxyl. But because here we have two carbons here for hydrogenation and hydration, we only have two carbons here. We don't have to worry about applying Markovnikov's rule of whether of forming the major product there, giving our hydroxyl group or our halogen the highest possible carbon number. Here we can put it here or here. It doesn't matter. Here or here, it doesn't matter. It's still on carbon number 1. This is only, especially only for this case, whereby we have only two carbons here, whereby it doesn't matter where we put our OH. Otherwise, when we have the option between putting our OH on carbon number 1 or 2 on 2, 2 or 3 on 3, according to Markovnikov's rule there. Here we don't have to apply Markovnikov here. Okay, now hydrogenation is again breaking that triple bond, and the product there becoming an alkane, whereby now after breaking the double bond with the hydrogenation, what we add actually is two hydrogens. So what we have is an alkane. So compound A is 1-bromoethane. Ethane 1-ol. So definitely this has to be carbon number 1. This will be carbon number 2. There's only 2. So this is ethane 1-ol there. And then this will be ethane. Oh, it's already there. It's ethane. This will be 1-bromoethane there. So 4.1 says, what type of reaction is represented by reaction B? Write down addition or substitution. It is a reaction whereby an alkene reacts. Alkene reacts as a reactant is going to be an addition reaction. So the 4.1 is an addition reaction. 4.2, write down the name of the inorganic substance that is needed for this reaction to form an alcohol. What is the inorganic reactant then? So in other words, they're asking us, is an alkene plus what? And for us to get this alcohol, is an alkene plus what? So 4.1, we said that 4.1, our reaction is an addition. It's an addition reaction. 4.2, the inorganic reactant is water. The inorganic reactant is water. 4.3, write down the structural formula to write down or use structural formula and write down the major product of compound B. Compound B, the alcohol. Here it is over here. I'm just going to say here, this is 4.3. Our product after adding water, breaking the double bond, and adding water, adding hydrogen and OH there to give us that alcohol over there. That will be our product over there. 4.4 says, identify the type of reaction that is represented by reaction A. If hydrogen bromide is added to ethene, write down the full reaction name. Now, when we add a hydrogen halide, hydrogen bromide is a hydrogen halogen, it's a hydrogen halide. The reaction is called a hydrohalogenation. It's called a hydrohalogenation addition reaction there. Okay, 4.5 says now, give the IUPAC name of compound A. Compound A is this one, 1,2. This is 1-bromoethane. is 1 bromoethane. So it takes you back to doing the first organic nomenclature part of the IUPACs and such. So one over there, 2 for that structure over there, 1 over here, and then 1 over here as well there. Oh, okay. 2 for this one. Okay. Now 4.6 says write down the balanced chemical equation where ethane is burned in excess oxygen. It's a combustion reaction there. Now let's see there what we can do here. Let's see. Let's have ethane. What we know about ethane is that it's an alkane with 2 carbons. But how many hydrogens? You can simply just count them. 1, 2, 3, 4, 5, 6. So we have H2, C2H6. It reacts with oxygen. This reaction, complete combustion, always gives you carbon dioxide and water there. Carbon dioxide and water there. So to balance it, we say we have 2 carbons this side. So if we have 2 carbons on the left hand side, we must make sure that we have 2 carbons on the right hand side as well. We multiply by this coefficient of 2 on the carbon dioxide. Now we have 2 carbons there as well. Okay. Now what about hydrogens? We have 6 hydrogens on the left hand side, and then how many hydrogens on the right hand side? Only 2. So now we must multiply this 2 by 3 so that we have 6 hydrogens, 2 times 3, 6 hydrogens also on the right hand side there. All right, now now we count how many oxygens we have. Now the number of oxygens that we have here is on the right hand side first. 2 times 2 is 4 plus 3 times 1 is 3. 4 plus 3 is 7. So we have 7 oxygens on the right hand side. So we must make sure that we also have 7 hydrogens on the left hand side. So we are going to multiply this oxygen of ours we are going to take that 7 of ours and divide it by 2. So 7 divided by 2 is a fraction. So now what we are going to do to make sure that this balances out is to multiply everything by 2. Meaning now we multiply here by 2 is 2C2H6, multiply 7 over 2 by 2 is simply just 7. Multiply 2 by 4 by 2 is 4 carbon dioxide, plus multiply this 3 by 2, it's 6 waters there. So this is a balanced combustion reaction for ethane then. Okay, to recap, let's recap a little bit there. Okay, so what we did at first is that we said that now the first 3 reactions, A, B, and that hydrogenation there are addition reactions whereby we break the double bond and then form our product from breaking the double bond and adding. Now the question is always, what are we going to add? Now sometimes it's clear like here, they tell us here we are adding hydrogen gas. Now after you break the double bond, we add 2 hydrogens there. So it becomes an alkane. And then immediately after that, I give it a name, is ethane. And then for this one over there, it's clear that we add hydrogen bromide. They tell us we add hydrogen bromide. Okay, so we know when you add hydrogen bromide to an alkene is when you add hydrogen bromide to an alkene over there, the reaction is a hydrohalogenation. And then now hydrohalogenation, you know, something that I don't see from this question is conditions is that hydrohalogenation will be an reactive solvent and no water, and then platinum catalyst required for hydrogenation, and then sulfuric acid catalyst for hydration. So if we are going to have an alcohol from an alkene, we must add water. So the water will be the inorganic reactant in the reaction B there, and then it requires sulfuric acid as a catalyst there, that reaction there. So once I have the product, and I have the names of the reaction and the inorganic reactants there that are added to our organic reactants, then and the conditions, then I can start answering the questions. So ethane, 1-bromoethane, ethan 1-ol, the alcohol formed by hydration. Then I can start answering the questions here. And lastly, the combustion of the alkane there. So 4.1 it was saying there was this reaction B, addition or substitution. It's an addition. It's from an alkene. Breaking of double bonds and adding atoms is an addition reaction. Write down the name of the inorganic reactant needed for reaction B. For hydration, I need water. And then use the structural formula to write down the major product of reaction B, the alcohol that is formed, as we have already dealt with that there. Breaking the double bond, adding H and OH from the water. Identify the type of reaction that takes place for reaction A. When you add hydrogen halide, is hydrohalogenation. The IUPAC name of compound A already dealt with them. As you give the product, also give the name there, just in case they require it there. And then for the combustion reaction, that's why now we say now the molecular formula of our alkane plus oxygen give us carbon dioxide and water, and make sure that you balance that as well. Okay.